Hello everyone, I'm Vibhor Singh, and today we'll be discussing the 30th problem of the CP-31 sheet under the 1300 rated parameter. So as you can see, this is the CP-31 sheet and 30th problem is average sleep time. It's been almost a week since Polycarp couldn't get rid of insomnia. As you may already know, 1 week in Berland lasts 8 days. When Polycarp went to a doctor with his problem, the doctor asked him about his sleeping schedule, more specifically the average amount of hours he slept per week. Luckily, Polycarp kept record of sleep times for the last n days. Now he has a sequence A1 to AN where AI is the sleep time on the ith day. So the number of records are very large, so he cannot calculate the average value by himself. Thus, he's asking us to calculate it. To get the average, Polycarp is going to consider k consecutive days as a week. So there will be n minus k plus 1 weeks to take into consideration, and then they've given an example. So in the end, we have to calculate the average sleep time of Polycarp over all weeks, and it says that the relative error should not exceed 10 raised to minus 6. Okay. So let's take this first example 3, 2, and then 3, 4, 7, and try to understand what the problem is saying. So we have 3, 2, and then we have 3, 4, and 7, right? So now 3 represents n, that is the number of days whose sleep time we have, or the number of days for which we have the sleep time, and 2 is the number of days in 1 week. So basically what happens is these two together is 1 week, first 2 days, and then this is another week. So there are 2 weeks, that is n minus k plus 1 weeks, right? So 3 minus 2 plus 1, that is 2 weeks. So we have data for 2 weeks. Now what do we have to calculate? We have to calculate the average sleep time over all weeks. Okay, so we have 2 weeks, right? So our denominator just becomes 2, right? Because we have 2 weeks, and a numerator becomes the sleep time in week 1 plus sleep time in week 2, right? So in the first week we have 3 plus 7, that is the week time in the first week, right? Sorry, 3 plus 4. 3 plus 4 is the week time, sleep time in the first week, which is 7, and then 4 plus 7 is the sleep time in the second week, right? Which is 11. So we'll get something like 7 plus 11 by 2, which is 9. So we get the average sleep time over all weeks. That is average sleep time for 1 week over all weeks is 9, and that is what is given to us. And we have to predict it, and we have to make sure that a relative error does not exceed 10 raised to minus 6. So that's it for the problem discussion. Let's see the expected time complexity. We are given n and k are till 2 into 10 raised to 5, right? So n comma k is still 2 into 10 raised to 5. And we know 1 second in Codeforces corresponds to approximately 10 raised to 8 operations. So anything of the sort of order of n plus k, or order of n log n plus k, or k log n even, k log k even, or k log n, anything like that, something like that will work. But if you go in the order of n square or order of n into k, then we'll get TLE. So that's it for the expected time complexity discussion. Let's try to understand how we can solve the problem. See, the problem is very straightforward, right? You have week 1, then you have week 2, then we have week 3, right? We'll get some values of the total sleep time for that week, which will be the sum of values in this each of these subarrays, right? Of length exactly k. So this is like a we can see a sliding window here. That is, we have k length of window, and each k length window represents 1 week. The sum of that 1 week will represent the sleep time of that week, right? And then after that, let's say we got S1 as sleep time of week 1. So we got S1, S2, S3, so on and so forth till S of n minus k plus 1. That is, n minus k plus 1 is the total number of weeks we will have. Then we will add all these values. So sum of all these values, so S1 plus S2 plus S3, so on, sum of all these values upon n minus k plus 1 would be our overall answer, right? Now, how do we calculate the sums? Or in a sliding window, what we can do is, initially we'll have two variables. We'll take sum and we'll take total sum, right? Or something like that, or total sum can be anything, right? Like the variable names can be anything. Basically, sum represents the sum of a current week, and total sum is sum of over all weeks, right? And this is sum over all weeks. So how do we calculate our sum? Initially, we'll run a for loop from I will run from 0 to k, right? That is I less than k. So basically till k minus 1, 0 to k, right? For the first k values, we'll calculate the sum, right? We'll calculate the sum for the first key values. This is our value for the first week. After that, what we need to do is we'll need to remove the last value and add the first value or the next value, right? We'll just move our window forward. How we'll do it? We can look at it through the code itself. Basically, we'll move our windows forward. We will add sum into our total sum for each of the windows, and then in the end, we'll do total sum upon n minus k plus 1, and this will form our answer, right? Now there will be some implementational details in this solution because we have to handle overflows of integers, we have to handle precision till 10 raised to 6, right? So that would be the problem has more around how you are going to write the code than actual logic of solving. So I think we'll just move on to the code and try to understand how we are solving the problem. So we have n comma k as the input, and then we are taking the vector as input. I've taken answer. Basically, answer is to calculate the final answer, but is also calculating the total sum to start with, right? So instead of answer, let's just call this total sum. So total, I've taken total sum and sum both as long ends because if we take it as integer, then it will cause overflow, right? Because we have basically we have n is till 10 raised to 5 and AI is also till 10 raised to 5. So even if our k can be till 10 raised to 5, right? So overall sum can go till 10 raised to 10. So that is why we need to take long end for total sum and sum. And then initially we calculated sum for the k first window that is of length k. Then we just added sum to the total sum. Since total sum was initially 0, you can use equal to directly instead of plus equal to. And we have the two pointers. P1 is at 0, P2 is at k, right? So these are the window length. Basically what is happening is I have 1, 2, 3, 4, 5. Let's say I have this, and my window length is of 3. So initially I took sum of first three values. My P0 is, or sorry, my P1 is 0, and my P2 is I've taken as 3. Okay. And the indices are 0, 1, 2, 3, 4. Okay. These are the indices, zero based indexing. Okay. So, what I have to do is I have to remove this value and I have to add this value, right? So, my P2 represents the value I have to add while moving the window, and P1 represents the value I need to subtract while moving the window. So, my new sum will just become old sum. So, like if I try to write new sum is equal to old sum minus vector of P1, right? V of P1 plus V of P2, right? Plus V of P2. Since P2 is ahead the window, right? I haven't taken P2 as K minus 1, that is the last element in the window. I've taken P2 as the next element we have to add. So that is why, since P2 is K, it will directly add the next value. So we'll do this and then we'll just say P1 plus plus and P2 plus plus, right? We'll just increment both these values. So this is how we are implementing our calculation of sum for each of the windows using two pointers. So while P2 is less than n, in the sum first we'll subtract V of P1, then we'll add V of P2, and then in the total sum we'll add the sum, that is the new sum we have gotten for this new window. And then we are incrementing P1 and P2. So this is how we are calculating the total sum. And then in the end, we have to print till precision 6, and also we have to use fixed here to ensure that the answer is calculated till the precision, right? Because if you not use this, you directly just print it out, it will go something like how C++ will do it, put like something like 2.5256 into 1e6. It will form the answer something like this. It won't calculate to the precision that we want. So to calculate to the precision we want, we put fixed and then we use set precision to print till 6 integer digits, and then finally we print or we use set precision to print till 6 decimal places rather, sorry. And then in the end we do 1.0 into total sum upon this. Total sum was a long variable, it wasn't a double variable, that's why we have to do 1.0 into total sum divided by n minus k plus 1, and that's how we are printing the solution. So let's look at the time complexity of this solution. So taking the input is of order of n, right? Then calculating the sum over here is of order of k, right? Then this overall while loop, it will run for overall how many times? See, it is in one iteration, it is calculating for 1 week, right? So it will overall run in for n minus k plus 1 at max, although it won't even be plus 1 since we have calculated the first week over here. So only n minus k weeks will remain. So this loop will run only for n minus k operations, right? So overall time complexity will just become n plus k, right? We can just say overall time complexity is equal to order of n plus k. Uh, and also we can just write it as order of n since k will always be less than n, right? But that doesn't matter if we write order of n or order of n plus k. Then for the space complexity, we have taken a vector of length n as input, and then there's no other additional space. So overall space complexity of the solution also becomes order of n. So that's it for our solution discussion. I hope you were able to understand it. Thank you.